Welcome to 1.2 mass spectrometry. Okay, 1.2 mass spectrometry of the AP 1.2. Okay, the most important message is please subscribe. Please subscribe. It's very important. Okay? It will help us. Okay, please subscribe. So 1.2 mass spectrometry. Okay, so the first important thing that we are going to understand today is how the mass spectrometry first, the mass spectrometer works. And initially we know some of the constituents about the atom. Okay, let's first try to what we know as of now. We know that the nucleus is a dense area where you have both protons and neutrons reside, and the electrons go around in definite orbits, and the protons and neutrons are almost 1,000 times heavier. Each of them are heavier than electrons. Okay, that's very important. That's the first understanding. Now, if you take any representation, okay, so if you take any representation, how we write the isotopic notation, if you take carbon, you write C612. The 6, this one is called a subscript. This one is called as a superscript. The subscript always refers to the atomic number. The atomic number is nothing but the number of protons. Okay, it is not the number of electrons, it is number of protons. Why? Because the number of electrons might change. Okay, the electrons might change, right? In some cases it can form both cations and anions, right? It can lose electron or it can gain electron. Okay, so it's very important. So atomic number always refers to protons, okay, because they're inside the nucleus and it won't change. Next is the superscript mass. The mass number is always both protons plus neutrons. So if I have to find neutrons, you want to find neutrons, all you have to do is to subtract mass from atomic number. It's very easy. It's an easy process. Okay? But you have to remember this. Easy means you have to remember. So if I have to find out how many isotopes are there, usually if you take any solid, let's say that we have to find out certain amount of how many isotopes are there in carbon. So if you take carbon is a solid. You first heat carbon is going to become a liquid. And then if you heat further, it is going to become a gas. And then if you go heat further, it is going to form now carbon gaseous ions. Now, when they form ions, it can form several species. Okay, carbon 12, carbon 13, carbon 14, and so on. So we don't know how many isotopes are there, but we assume, let's say that the 3 isotopes. So how the isotopes, the mass spectrometry works is, if you inject a sample here, and then if this will hit the hell out of it, and then it will make the gaseous ions, and these ions will pass through and deflect through the magnet. And then once the magnet starts deflecting, it will separate the isotopes based upon their weight. Since the neutrons are different now, the lightest will be carried further away. Okay, so the lightest will be carried, the heaviest will stay in the same path, and the lightest will move farther away. And then you can see that it will report now, I see 3 isotopes. I see 3 isotopes in the definitive ratio. So it might say, oh, I see 84%, 12%, and the rest is C14 or something. So this is rough estimate I'm giving. So something like that. Okay. So if you take hydrogen has 3 isotopes: hydrogen 1,1, hydrogen 1,2, hydrogen 1,3. You have the protons, electrons, and neutrons. You have 1 proton, 1 electron, and 0 neutron in the protium. In deuterium, you have 1 proton, 1 electron, and 1 neutron. In tritium, you have 1 proton, 1 electron, and 2 neutrons. Okay, so if you put it in mass spectrometer, it will say you have 3 isotopes in a definite ratio. Okay. So if you want to find out, I'm going to give the link. Okay, so you can find out how many isotopes in each element it can have. So if you click anything, it will tell you what are the major isotopes and in what ratio you have. Okay. So if you go to periodicptable.com, also, if you hit isotopes, it's going to give you a varied number of isotopes. Okay, but this is like too much. But this one is the correct one with several isotopes these are the major isotopes that is available. So that is important. So this is how the spectrum will look like. Okay, usually the spectrum looks very easy. So if you look at this spectrum, the mass spectrum of the elemental bromine is represented below. Label each peak with the appropriate nucleate symbols. Remember, not all elements exist as single atoms in nature. Now you have, at 80, you have 2 peaks. Okay, sometimes the isotopes can be very easily identified. Okay, now before we go into this question, let me explain to you something most important. So what in this case of isotopes, what are the characters of these isotopes? First we have to understand before we go into these problems. The isotopes are the same species, right? So they exhibit identical chemical behavior. Okay, this is very, very important. Okay. So in other words, if I have hydrogen 1, hydrogen 2, hydrogen 3, the protium, deuterium, and tritium, when it reacts with oxygen 16, oxygen 17, and oxygen 18, it can form, each of the hydrogen can react with 3 oxygens and can form 9 different species of water. So there are different species of water, but the body cannot differentiate the water we take in. Why? Because for it reacts only chemically, right? The chemistry is only with the electrons. The differentiation is only in the number of protons, number of neutrons. Where does the neutron reside? The neutron reside only in the inside the nucleus. Okay, it's very important. Right? The same thing in case of carbon, C14, C12. When it reacts with oxygen, it's going to form several species of carbon dioxide. Okay? And we breathe in several species of oxygen. But the difference is only in the neutrons. Chemically and electronically, they are all same. So their reactivity is also same. So this is very important. Okay. The atomic mass is all related, right? So this is all based upon carbon C12. Okay. Carbon C12. Carbon is the basis. Okay. And whatever you see in the periodic table, is the average atomic mass. The average atomic mass is nothing but the average of all the isotopes, So that is very important. So if you look at the ptable.com, if you look at the value and you see chromium has a value of 51.996, that means this value is dependent upon several isotopes of chromium. If you look at oxygen and it says 15.99, it is depends upon several isotopes of oxygen. Okay, so that is very important. Now, to calculate, there is a formula. Okay? So if you want to calculate average atomic mass, the average atomic mass is not like the regular atomic mass. So if you take sigma means sum of all the relative abundance of isotopes. Let's say there are n of them, there are n isotopes, times the mass of isotope. N of them. And then you add them. Okay. So let's look at an example. Let's say that the peak shows like this. The mass spec, the exam, so the mass spec peak like this. So this is the relative abundance. So it shows that there is a peak at 24, there is a peak at 25, there is a peak at 26, and this is the almost 78.99%. Here I have a 10%, here I have 11.01%, like that. So this is the one that's given here. So if it's given like this, then how will we find out what is the relative, what is the element we are talking about? So what you do is, if this is 78.99%, you take 78.99 divided by 100, multiplied by 24, that is the mass, plus 10 divided by 100 times 25, plus 11.01 divided by 100 times 26. Calculate everything, you will end up with 24.3. You go and check what number is related in the periodic table. You go to the periodic table, where is relatively 24.3, right? And then you will see that 24.3 is roughly magnesium, because 22.9 is sodium, the another one is 26.9, so obviously magnesium should be the answer. So now sometimes the it might look like this. Okay, in the AP, they might give you something like this. The mass spectrum, the elemental bromine is represented below. Each peak, label each peak. Now you look at this one. You have it between at 80, there is two of them. Okay, there is one at 79 and 80. And exactly at 160, there are a couple of them. Okay. So if you see something like this, usually what happens in the mass spectrum, it gives you the first time when you see the isotopes, it will give you a set of peaks. Those isotope peaks, okay, now it tells you there are two isotopes here for the same element. One is 79 and one is 81. And then if you double them, that means we are talking about a diatomic molecule. Okay, now we have to figure out which one is 79 here. 79 mass is close to 79 and 81 is very roughly here. Selenium, bromine, and potassium, and 79 is this one. We know that this guy is a diatomic molecule because bromine is diatomic. Nitrogen exists as N2, O2, F2, Cl2, Br2. So bromine is diatomic molecule. So this is talking about bromine here. So it is first is talking about 79 bromine. So answer I'm writing here. So 79 bromine, these are the fragments, 89 bromine. But now these guys are talking about the fragmentation of 79, 79, 79, 81, and 81, 81. That is the reason it shows up as molecular ion peaks. So this is a molecule. It is a bromine peak. It's a diatomic peak. Okay, so you should be knowing what are fragments are called isotope peaks and what is called as the molecular ion peak. Okay, so you should be aware of this also. Okay, mostly many people will not cover this. Next type is the mass spectrum below represents a mixture of elements. What elements are present? How do I know it is a mixture of elements? Here, I clearly see that 80 into 2 is 160. Here, 74 into 2 is not 107. So obviously, this is not a molecular ion peak. So I know that 74 and 107 are two different things. And I know it's mixture of elements. And one is 74. And one is 107 and 109. And now when I go between 107 and 109, if I go and check, where is 107? 107 and 109, there is 107 I have, but I don't have 109. So I know that this guy is talking about a silver, which is having two isotopes, and it's talking about 74.2, which is going to be arsenic, because 72 is germanium and 78 is selenium. So it should be talking about this guy. So the answer must be arsenic, and this should be silver 47107 and silver 4711. So this is how you are going to identify based upon looking at the periodic table. Okay, so let's look at some AP level question. There are two stable isotopes of calcium 40, calcium 46. Using the average atomic mass of calcium from the periodic table, calculate the percent abundance of the each isotope of calcium. So how to do this thing is you have been given 40 and calcium 40 is 39.96% and 46 is 14. The overall value is 45.95. He is asking you the percent now. Okay. So how to calculate the percent relative abundance? Okay, the overall mass. So the exact mass of 40 is 39.96. The exact mass of 46 is 45.95. Okay, so how to find out the relative abundance? So what we should do is we have to keep the whole thing. We have to keep calcium 40 as X and calcium 46 as Y. But we know that X plus Y is going to be 1. So Y is going to be X minus or 1 minus X. Okay, we have to solve for X. Okay, so how we are going to solve for X? We are going to do like this. Earlier we did in a different way. So we are going to take 39.96 times X plus 45.95, 1 minus x will be equal to the number in the periodic table. Okay, so what is the molar mass of the periodic table in calcium? Calcium is going to be 40.078. And you solve for this, minus 5.99x is equal to minus 5.87. X is equal to 0.98, which will be 98%. So calcium 40 will be 98% and calcium 46 will be 2%. So if this is 98, this will be 2. So this is how you're going to solve this. Okay, so this is very simple. It's a different algebraic way of solving this. Okay, so this type of questions will always come. So here, earlier method, we did what we did was we the percentage was given. Okay, so we had a simple way of percentage was given, and then you multiplied by the mass, and then you found out the overall mass. That is type 1. But the type 2 question here, here is you're solving for the percent abundance. Okay, this is given, this is given, this value is also, we are taking it from the periodic table, but we are solving for the percentage. Okay, so be careful about this. Try to solve some of these problems taking from the Zumdahl book and so on. Okay, this is one of the questions that you might encounter in the AP. Okay, see, a mixture of elements were analyzed using a mass spectrometer. The following graphs were created. Based on the graph, which of the following statement is correct? So it gives you one peak and it gives you a set of peaks. One is 50, another one is 35.5, 5.5. So what is the correct answer? The sample contained different quantities of 4 elements. So does it get different quantities of 4 elements? The sample contained one element with 4 different isotopes. Does it have 4 elements with, if you have a sample contain one element with 4 different isotopes, means they should be very close to each other. Okay, that is not true. So B is totally wrong. The sample contain equal quantities of 2 elements, only with 1 isotope and one with 3 isotopes. The sample contain 100 elements with 4 different isotopes. That is totally wrong. So B and D are totally wrong. So a sample contained different quantities of 4 elements, each with only 1 isotope. Does it have any mass will have an isotope with mass 5, 5.5? No, 4. And it's not going to come at the end anyway. So that is also cannot be correct. So A is wrong. Okay. B is wrong. One element, 4 different isotopes. That is also wrong. D is also wrong. The only correct answer here is only C. The sample contained equal quantities of 2 elements, because it's 50 and another one is 39.5 plus another 5 plus 5.5 is also 50. So it's overall, it has 50, 50. Overall, it's 100 with only 1 isotope and one with 3 isotopes. That should be the correct answer. So sometimes in the AP, this is how they will ask you, they will say two choices you can easily skip, and you have to debate between another 2 choices, and you have to pick the best one of them. Okay, so that's called the process of elimination, and we will look into this exam strategies at the close to the end of the year. So you have to be practicing more on this problem. So as I told you, we have learned the concept. Okay, so concept learning is not success. Concept learning is one part, but this enduring understanding. Okay, so solving problems is the key. Okay, that's very important. Okay, we'll see you in the next class. Please subscribe the channel.